Okay, so we're going to walk through the fetch, decode, execute cycle. Now this is a cycle that happens thousands of times a second every time your CPU goes through one of its cycles, okay, and we refer to that as hertz. So the animation, okay, is going to show you the process of fetch, execute, decode cycle of the CPU, and some of the steps are simplified in aid of understanding. Okay, so all that means is some of these steps in the actual CPU, there is a few more things going on, but for the sake of our exams, this will be absolutely fine. So let's run through what we've actually got on here. So we've got the accumulator, which accumulates the current number being used. The arithmetic logic unit, where all the maths goes on. Our registers. Now the registers are a small bit of memory actually on the CPU. We've got program counter, memory address register, memory data register, current instruction register. And below here we've got the control unit, which actually controls all of the actions within the CPU. And then we've got this external memory, okay, so this would be our RAM. And you can see in the external memory we've got instructions. Now these will be important. And in the bottom right hand corner you can see we've got a little key here. When you see a red dot, that means that it's going down the address bus, green dot data bus, and blue dot control bus. So I'm just going to press play and we're going to see the first step now. The program counter is currently set to 1 because this is the first thing to happen. Notice that when I press play, it takes this number 1 and puts it into the memory address register. Okay, so the memory address register is now going to look at the number 1 in memory and it's going to take that memory address through the address bus along with the control unit sending a piece of information down the control bus, and it's going to go to the memory address number 1. And in this address we've got some data that says load 5. So notice we went down the memory address register, went from the memory address register, down the address bus to the memory address number 1, and it's coming back down the data bus with the data load 5. And that's gone straight into the MDR. Because that is the current instruction that we're going to do, it's taking it from the memory data register into the current instruction register and goes over to the control unit. Okay, so it's going over to the control unit to be decoded. Now, the reason this is happening is because in memory this will be stored as some numbers. Okay, so these will be binary numbers and our CPU actually needs to know what is going on. So we've got load 5. Load 5 is in the control unit, and the control unit said I'm ready for the next instruction, so it sent a little incrementation to the program counter and said get ready for number 2. And it is also sent from the control unit the value 5, okay, because it says load 5. So we're going to put the number 5 into the memory address register to load 5, address 5. We're coming back down that address bus from the address register with a little bit of data from the control unit, and we are going to address 5. Now address 5 in our memory has the data number 12. So on the back, we've got the number 12 coming through this data bus, going to the data register, which, because it hasn't actually got an instruction, there's no need for it to go to the current instruction register. It's going straight over to the accumulator. And from there, we're done with that part of the process. And our address register is now having the program counter number copied over. So we're now looking for number 2. The address is going across the address bus, so from the memory address register, through the address bus, up into memory. Remember, we've got that little bit from control unit as well. but going from the memory address register through the address bus to number 2. Now it's going to come back with the data of add 6. So it goes to the memory data register along the data bus, add 6. Now it's going to take that, copy it into current instruction register because we've got a full instruction. It's not just a number, it's a full instruction. That goes across to the control unit, and you can see here in the control unit we now have add 6. So this is being decoded before we can actually execute. So notice how we've got the instruction fetched, it's then decoded, and now we're going to execute that. Increment to 3. We want to add 6, so we're going to get the number from 6 and add it to whatever is currently in the accumulator. So we've gone from the memory address register all the way down the address bus to number 6, add 6. We're going to get the data number which is in there, which is actually 8. It's come all the way back to the data register, going across the data bus into the accumulator. Now we can only have one item at a time in the accumulator, so we know that we need to do some maths. We take 12 and 8, a little bit of the control unit comes across that says add. Okay, we both go to the ALU and we get the number 20. Okay, 12 plus 8 equals 20. Program counter, which was incremented earlier, goes to number 3, goes across the address bus. We get the data that says store. So we're going to store it in the number 7. CIR because it's an instruction. And the same as what's been happening before, we increment. We take it from the address register, the number 7. Take that number from the accumulator, number 20. So you can see here in the address register we've got 7, so that will be the address. The data to go into that address is 20, and the instruction is to store. So store in address 7 the number 20. Goes down the address and data bus, and there we go. In 7 we've got 20. This finalises the store instruction and the result is now saved in memory location 7. Okay, so that was our full fetched, execute, decode cycle. So every time you have a hertz on a CPU, so let's say our CPU is running at, it wouldn't run at this, but if it was running at 5 hertz, this would happen 5 times a second. Obviously our CPUs now run around 5 gigahertz, so this is happening thousands and thousands and thousands of times a second. So I hope that has cleared it up. Obviously you can go back, replay through. If you have any issues, don't be scared to just leave a little comment below and I'll try get back to everyone.